conic sections in polar coordinates. Now, let's see. Theorem 6 says that a polar equation of the form r equals E times D over 1 plus or minus E cosine theta, or R equals E times D over 1 plus or minus E times sine theta. So it says that the polar equation of this form represents a conic and is, like I mentioned earlier, and is a an ellipse when E is less than 1, B, a parabola when E equals 1, or C, a hyperbola when E is greater than 1. So, for all you visual learners, to better understand Theorem 6, we'll try to sketch it so you can actually understand what actually Theorem 6 says. So for example, when R equals E times D over 1 plus E times cosine theta, your graph should look like this. So in this case, we're saying that this is a parabola, which E would equal 1. And so this is our focus. And that's one thing you also need to know, that for this, our focus has to be at the origin, meaning 0, 0. So it has to be here. So 0, 0. And our directrix is, since it's plus E times cosine theta, it's obviously on our x-axis, and it's plus, so it's going to be on our right side, not on our left side. So a directrix should be on the right side. So this is our D, which would be x equals what our D is. Okay? Let me put that in black so you can actually see it. So x equals D. And when R equals E times D over 1 minus E cosine theta, our graph, or sketch, not graph, our sketch should look like this. This is our focus. This is our directrix. And our directrix here would be x equals negative D, since it's on our left side. And if you'll start seeing the pattern. So here, since plus E cosine theta, our directrix is on the x-axis, on the right side, which means positive. Since here it's negative, so here it's minus E times cosine theta, it's going to be on our left side, meaning still on our x-axis, but this time our direction is going to be negative. So it's going to be kind of similar to the other one. So r equals e times d over 1 plus e sine theta. So our graph should look like this. So that's our focus. And this is our parabola. And our directrix is this. And now, in this case, since it's plus e times theta, it's going to be positive, and instead of writing x equals, we're going to do y equals d. And positive d because it's plus sine theta, so it's going to be above the vertex, so the vertex of the parabola, which is similar to our last one, which is r equals e times d over 1 minus e times sine theta. And so this one, graph, is going to look like this, our sketch. It's going to be our focus, parabola, and this time our directrix is below the vertex, so it'll be here. And now this one is going to be y equals negative d. Okay? So this one, putting it this way, it's actually more understandable in what in a Wade theorem success. Oh, okay. And if you also look into if you look at in our book, you will also see, I believe it's page 705, you will see how the graph changes as e changes. So you'll start seeing that as e is less than 1, you'll start seeing an ellipse. And as c is getting closer to 0, it starts getting closer to being a parabola. And as e becomes greater than 1, you'll start seeing how it starts becoming a hyperbola. It's pretty cool. You should check that out. But because of time and because of space, this is what I am able to actually show you. So it's more understandable actually seeing the picture, doing it yourself, and seeing what exactly it means. So having this in mind, let's start doing our examples. So in this section, there's actually 2 different ways they'll ask you for this information. So we'll start with the first way. So the first one, it'll ask you, they'll give you the details, what I like to say the details. So they'll give you the eccentricity, they'll give you the directrix, and they'll give you what type of conic it is. And your job is to put it into the conic form. So everything will be given to you, and your job is to put it into the form, which is, I believe, the easiest one than the other one. But either way, both, as you understand it, and the more you do it, the more practice you put, the more you'll get the hang of it. So our first example, number 1, it is given that it's an ellipse. The eccentricity is 1/2 and the directrix is x equals 4. So from here, from just what it's given to you, you should take a look at this. It's an ellipse. Why? Because our e is less than 1, which is 1/2. So that's what's an ellipse. Now look at our directrix. It's x equals 4. Look, it's x. So that means x-axis, which means cosine. It's positive, which means that you will be using the plus e times cosine theta. That's the first thing I recommend you to do. The first thing I do when I did the homework for this section. So I will look at this, and the first thing that I will look is my directrix. Okay, is it y or is it x? And is it positive or is it negative? Because either on this, it's when we get to decide which one of these it is. So since it's positive 4 and it's x equals positive 4, then the one you will be using is this one. Is that one. So now that you know that you'll be using that one, we write the actual formula. So it would be r equals 1 over, e times d over 1 plus e cosine theta. And we make a list. So my e equals 1/2. My d equals, my d is x equals 4, which would be d equals 4. Alright, so now that we have that in mind, all we do now is just plug it back in there. So we get r equals our e, so 1/2 times our d, which is 4, times 4 over 1 plus our e, which is 1/2 again, times cosine theta. So this becomes 2 over 1 plus 1/2 times cosine theta. Now this, if you leave it like that, it's still correct, obviously. But I guess you can see that it looks kind of messy. So what we want to do is we want to be able to multiply times 2 so that we can get rid of that 1/2. So if we multiply times 2 here, we have to multiply times 2 on the top. So we do that, and our final answer would be r equals 4 over 2 plus, that would be 1, so just plus cosine theta. And that would be our answer for that one. So you see, it's not that very hard. It's very, very simple. So let's do our next example. So for this one, it is given that it's a hyperbola. Our eccentricity is 3. And our directrix is r equal to -6 cosecant theta. Okay? So now, if you actually look at this, and we recall from 10.3, we'll actually see the resemblance here, because if we copy it down here, r equals -6 cosecant theta. If we actually divide cosecant theta to the other side, we have r is over cosecant theta equals -6. And this is technically 1 over cosecant theta, which is sine. So we have r times sine theta equals -6. And our sine theta is our y. So we end up getting y equals negative 6. And that's basically our directrix, okay? So now that we know that this basically means that y equals negative 6, we can actually now try to solve this and put it in its form. So we see that y, it's y, right? Y-axis, meaning it's sine theta. And it's negative 6. So that technically is telling us that we're going to be using the, minus e times sine theta, okay? So having that now, knowing that, we write down the formula. So we have e times d over 1 minus e sine theta, okay? So now we make a list. So our e equals equals 3. And our d, like we put it here, is, so our equation of directrix is y equals negative 6. But we actually want to put d here. We don't put negative 6. We just put 6. So don't get confused and don't write it incorrectly. So make sure that it's not negative 6. It's always, when you plug in d, whenever it's this kind of question and you want to plug in d, it's always going to be positive. It's not going to be negative. But when you actually do your equation of directrix, then you need to figure out if it's positive or negative, and you need to mark it down if it is negative. So our d equals 6. So having now that and knowing that now, we just plug it in. So we get 3 times 6 over 1 minus 3 sine theta, which we end up, our final answer would be r equals 18 over 1 minus 3 sine theta. And this is our answer. Okay? Alright, so example number 5. So we get r equals 9 over 6 plus 2 cosine theta. Okay? So, like I mentioned on this one, we need to have this be 1. So then we divide by 6, we divide by 6, we divide by 6. Okay? So we need to find our eccentricity, what kind of conic it is, and our equation of directrix. So once we divide by 6, we get that this equals 3 over 2 over 1 plus 1 over 3 cosine theta. So we know now that our E is 1/3. So E equals 1/3. And 1/3 is less than 1, of course. So our E is less than 1, which means it's an ellipse. Okay, so now we need to find our directrix. So our directrix we can figure out by this, because we know that 3 over 2 equals E times D. And we know what our E is. So we just plug that in, which is 1/3. We multiply times 3, multiply times 3. And we get that D equals 9 over 2. And we see that it's plus, which means it's positive. When it's cosine, so it means it's x. So it's x equals 9 over 2. Okay? So we're going to do one more example, and this time we're actually going to sketch the conic, because there will be questions where they'll ask you to figure out this and to sketch the conic. To be able to sketch the conic, though, you have to do one more step, which means you need to find your vertices. By finding your vertices, I'll show you exactly right now what we have to do. So, our last example, number 6, we have that r equals 10 over 5 minus 6 sine theta. Okay? So the same thing we have to do here. We need to figure out our eccentricity, what kind of conic it is, and our directrix. Equation of directrix. So we obviously want this to be 1, so we divide by 5, we divide by 5, and we divide by 5. And this equals 2 over 1 minus 6 over 5 sine theta. Okay? So we know what our E is. So E equals 6 over 5. And since 6 over 5 is greater than 1, therefore our E is greater than 1. So it's a hyperbola. Okay? So now we want to find our directrix. So we know that E times D equals 2. So we have 2 equals E times D. We plug in E, which is 6 over 5. We divide by 6 over 5. And we end up getting that T equals D equals 5 over 3. Okay? So, and we have that it's minus sine theta. So sine theta means y, minus means negative. So our equation of directrix is negative 5 over 3, which this is about negative 1.6666. Okay? We need to actually need to know this because we're going to need to graph this. So to be able to graph this, we need to know our vertices. And to be able to know our vertices, we need to let theta equal pi over 2 and 3 pi over 2. Okay? So if we let theta equal pi over 2 and 3 pi over 2. And the reason why we need to do this, because remember that we're still in polar coordinates. So sine theta is technically our y-axis. So we need this point and here, like here, pi over 2 and 3 pi over 2. If it was to be cosine theta, so plus or minus cosine theta, we need to do the x-axis. So it would be 0 and pi. 0 and pi. So this is the ones we would be doing for cosine theta. This will be for sine theta. So always remember, if you have plus or minus cosine theta, you use your theta, you let theta equal 0 or pi. If it's plus or minus sine theta, you let theta equals pi over 2 or 3 pi over 2. Okay, so now we plug it into our original conic form, not the one that we have reduced it to. This one, the original one. So we get r equals 10 over 5 minus 6 sine pi over 2. And so we get 10 over 5 minus 6, and sine pi theta equals 1. And so we end up getting negative 10. So our vertices for this is negative 10 pi over 2. Okay? So now we need to do it for this one. So r equals 10 over 5 minus 6 sine theta of 3 pi over 2. And so we get 5 plus 6, because sine of 3 pi over 2 is negative 1. Negative 1 times negative 6 is plus 6. And so we end up getting 10 over 11. And so our vertices for this would be 10 over 11, 3 pi over 2. And why is it in this form? Because we're still in polar coordinates, okay? So now that we have our vertices, we can actually sketch our conic. Okay. Let me sketch our conic. So we know the information that we actually need to be able to sketch our conic is our directrix. So our directrix equals y equal negative 5 pi over 3 or negative 1.66666. Okay? And what we need to know is our vertices, which is negative 10 to pi over 2 and 10 over 11 to pi over 2. Okay, so if we want to sketch this one, technically it would be right, this one here, pi over 2, 10, so it would be like, let's say, we count 10. But since it's negative, we actually go the opposite way. You should remember this from 10.3. So we would do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this here would be our vertices right here. This. So our parabola, because we figured out that it's a hyperbola, would be like this. Like that. And then our other vertices is 10 over 3, and 10 over 3 is about 0.9. Okay, so 0.9 is like, let's say, around here. So we do our vertices, our parabola right here. And remember, this is a sketch. Excuse me, my bad drawing. So this is a sketch, so it doesn't have to be perfect. But like I mentioned earlier, when we want to sketch this, we can't actually sketch it with just this. We actually need our vertices to be able to at least sketch it properly. So if we have that, remember that this here is our focus at the origin. Will always be at the origin. So now that we have that, we now do our directrix. So our directrix is 1.6, which is basically kind of like right here. So sketch our directrix right there. So our directrix is y equals negative 5 over 3. And we write down our vertices. So this is 3 pi over 2, and this one is negative 10 pi over 2. And that's how our graph would look like. That's how you sketch a conic. So I hope you found this helpful. I really liked it, and this is the end of my video.